Our first problem is 20 cards numbered from 1 to 20 are shuffled and one card is drawn from the pack of cards. What is the probability of getting a card numbered with more than 15 if it is known that the card is an odd numbered card? You can see in this problem already it is known that the card drawn is an odd numbered card. Therefore, this problem is a conditional probability problem. To do this problem in a very simplified way, we can consider that sample space. The sample space is 1, 3, 5, 7, 9, 11, 13, 15, 17 and 19. Because we already know that it is an odd number card. Therefore, there are total 10 elements are there. Now, favorable outcomes. 16 cannot be considered because it is not an odd. Therefore, 17 and 19 are our favorable elements. Therefore, total elements are 2. Therefore, our probabilities will be equal to total favorable outcomes divided by total number of element in the sample space. Therefore, 1 by 5. Therefore, 0.2. Therefore, option A is the correct option. Problem is 2 dice are thrown simultaneously. What is the probability of getting 5 appears on any of the dice if it is known that sum of the numbers appears is 7? That means it is also problem of conditional probability because it is already known that sum of the numbers appears on the dice is 7. Now, to do the problem in a simplified way, let us consider that the sample space where it is already known that the sum of the numbers is 7. Therefore, what is the possibility? 1, 6, 2, 5, then 3, 4, 4, 3, then 5, 2 and 6, 1. Therefore, total how many elements are there in the sample space? 1, 2, 3, 4, 5, 6. There are 6 are there in the sample space. What are the favorable here? Because favorable are that the 5 should appear on any of the dice. Therefore, here 5 appears on the second dice. Here 5 appears on the first dice. Therefore, our favorable outcomes are 2. And therefore, required probability is our favorable outcomes there are 2 elements and total elements in the sample space is 6. Therefore, it is 1 by 3. Therefore, the first option is the correct option. Option A is the correct option. Now, PA is given as 0.7 and conditional probability of B is given as 0.5, that is 0.35. Now, this 0.35 you substitute, therefore PB is given as 0.4 and we can find the conditional probability of A, and we can find A, that is 0.35 divided by 0.4, and that is equal to 0.875. Therefore, you can see here in the option C, 875 appears. Now let us find out the probability of A union B. That we know that is equal to 0.7 plus 0.4 . Therefore, both the options appears in C. Therefore, option C is the correct option. Next problem is machine A and B manufacture 40% and 60% of the bolt respectively. 5% and 4% are defective bolt manufactured by A and B respectively. A bolt is drawn at random and found defective. What is the probability that it is manufactured by the machine B? Therefore, you can see that the bolt drawn is already known that it is a defective bolt, and we have to find the probability that defective bolt manufactured by the machine B. Therefore, it is a conditional probability problem. Now, we consider that D is an event. We consider that D is an event of drawing defective bolts. And A1 and B1, A1 and B1 are two events of manufacturing bolts by A and B respectively. Therefore, you can see that probability of A1 is equal to how much it manufactures. It manufactures 40%. Therefore, 40 divided by 100. Therefore, it is a 0.4. And P of B1 is manufactured by the B. Therefore, it is a 60%. Therefore, you can say 0.6. Now you can see we can another thing, find the conditional probability that it is a defective bolts, and when we know that already, we know that it is manufactured by machine A. Therefore, what is the probability? That is 5% it manufactured defective bolts. Therefore, it is 0.5. And exactly in the similar case, that manufactured by the defective bolt manufactured by B1 is 4%. Therefore, and this is the case. Now we can apply the Bayes theorem here to find our required probability. By applying Bayes theorem we can find the probability of it is being manufactured by B knowingly that it is been a defective bolts. Therefore, according to the Bayes theorem, it is equal to P of B1 multiplied by then now we substitute the corresponding the values. P of B1 is how much? It is a 0.6 multiplied by 0.04, and here it is a 0.4 multiplied by 0.05, then 0.6 multiplied by 0.04. Now if you simplify now, you will see that here above it will be 24 and then 44 and then we'll get 6 by 11, and that is the required probability. Therefore, we can see our option here, or option B is the correct option. Can we solve the above problem in a simplified way? Now let us consider that total balls manufactured by A and B is X, and this is the ball manufactured by both A and B together. Now what is the, how many are manufactured by A? The A is 40% it is manufacturing. Out of that, how many are defective? 5% are defective. Therefore, this much bolts are manufactured, defective bolts are manufactured by A. That means 200 divided by of X. Exactly with the similar reasons, 60% are manufactured by B and 4% are defective. That much defective bolts are manufactured by B. What is the ratio of defective bolts? Manufactured by A and B. Ratio, I am talking about the ratio. It is 200 is to 240. Therefore, if the bolt is drawn at random and it is found to be a defective, and what is the probability that it is being manufactured by B? That is 240 divided by 200 plus 240. This will give you 24 divided by 44 and 6 by 11. And I think this is one of the easiest way to do the problem. Our next problem is, there are 3 bags. First bag contains 2 red and 6 white balls. Second bag contains 6 red and 4 white balls. Third bag contains 5 red and 3 white balls. A ball is drawn from one of the bags and found to be red. What is the probability that the ball is drawn from the second bag? This is a problem of conditional probability. Therefore, let us consider that A is an event of drawing a red ball, and B1, B2 and B3 are the events drawing the first bag, second bag and the third bag respectively. Therefore, P of B1, B2 and B3 all 1/3 equally likely cases. Now take another case, the probability of drawing a red ball when we know that the first bag already been drawn. Therefore, this is equal to 2 by 8, because there are 2 red ball and total number of ball is 8. Exactly in the similar reason that B2 second bag is drawn is equal to 6 by 10, and when the third bag a red ball is drawn, the probability is 5 by 8. Now by Bayes' theorem, we know that we can apply the Bayes' theorem, and we can find that what is the probability of drawing the second bag when a red ball is already been drawn. Therefore, this is, we can find This is the Bayes theorem. Now we substitute these values. Therefore, this is 1/3 6/10, 1/3 into 2/8, and again 1/3 6/10 and 5/8. Therefore, if we simplify, we'll see that this is 6/10 multiplied by 40/59. Therefore, if we further simplify, it will be 24/59, and that is our ultimate probability. And therefore, you can see that option B is the correct option. The next question is, in a particular area, 2% of the population are infected with malaria. In a laboratory test, 90% are detected truly and 10% remain undetected. The test also gives false positive result for 1% healthy person. What is the probability that a person has malaria if the test gives positive result? Therefore, we already know that test is positive, and we have to find what is the truly that person who is been tested positive has the malaria. Therefore, it is a conditional probability problem. Therefore, let us consider that A is an event. A person tested positive. And B1 is the event. A person truly has malaria. And B2 is the event where person truly does not has malaria. Now you can see that P of probability of B1, that means that person truly has malaria. It is given in the question that 2% person has malaria. And remaining people that who does not have malaria is 98%. That is the probability of B2. Another probability you can see that a person tested positive and it is already known that the person truly has malaria. What is the percentage? 90%. Therefore, probability is 90/100. Another is person already tested positive and we know that the person does not have the malaria. What is the percentage? 1%. They are falsely detected as a malaria. That means falsely detected positive result. Therefore, this is the 1%. It is given in the question. Now, by Bayes theorem, we can apply the Bayes theorem now. We have to find that the person truly has malaria when the person already have a positive result, and that is our findings. Therefore, according to the Bayes theorem, that is P of B1 multiplied by now we substitute the values. P of B1 is 2/100 multiplied by 90/100 plus here 2/100 multiplied by 90/100 plus 98/100 100, and we are just substituting the corresponding the values. Next, we just simplify that we are getting 180, and here 180 plus 98, it is 278. If we further review, this is 90 divided by 139, and that is our required probability. Therefore, you can see that our option C is the correct option. Can we solve this problem alternately in a simplified way? Therefore, let us try that alternate. Let us consider the total population is equal to X. Therefore, how many of them are truly detected? Truly detected people. How many have truly has malaria? 2% truly has malaria of the total populations. And how many of these truly are been detected in the lab? Therefore, 90% are detected in the lab. Therefore, 180 divided by 10,000 into X are the people who has been detected positive in the lab. Also, they have malaria. And falsely detected people, detected as positive. How many does not have the malaria? 98% does not have has the malaria. And how many of them are falsely detected? 1% are falsely detected. Therefore, 98 divided by 10,000 X are falsely detected as malaria. Therefore, whatever the ratio of them, 180 is to 98 are the ratio. And this is the actually they have malaria, and they have falsely detected. Therefore, if we want to find that required probability that those have truly has the malaria, those have been detected positive, that is 180 divided by 180 plus 98. Therefore, 180 divided by 278, and it is 90 divided by 139. And that is the way we can, simplified way we can find it out. Next problem is, an unbiased coin is tossed for 6 times. What is the probability of getting at least 4 heads? Now this is a case of a Bernoulli trials, because here there are finite number of trials. In this case it is a 6, and all the trials are independent, and there are only 2 outcomes, success or failure. In our case, success is getting a head and failure is the getting a tail. And in all trials, the probability of success remain the same, and therefore it is a Bernoulli trial. Now let us consider that P is the probability of getting head in a particular trial, and therefore Q is the getting a tail in the particular trial. Therefore, getting a head, our required probability of getting a head at least for 4 times. Therefore, first let us take the getting a head for 4 times. Therefore, what is the probability? This is the probability of getting head for 4 times. Now, next, or getting a head for 5 times. This is the probability getting a head for 5 times. Or getting a head for 6 times. And that is the 6 times. If you just simplify then you'll get that this is 15 into half to the 6. This is 6 and 6. Therefore, you are getting that 15 plus 6 plus 1, you'll get 22 divided by 64. Therefore, 11 by 32, and that is the option, and therefore option A is the correct option. The next problem is a pair of unbiased dice is thrown for 5 times. Getting a doublet is considered success. What is the probability of getting at least 3 success? This is a case of a Bernadette trials. Now first we have to find what is the sample space. The sample space for throwing 2 dice. Therefore, it is 1, 1, the 1, 2. In this way it will go, and there are 36 elements are there. And what is our favorable outcomes? That means success. Success is nothing but our favorable outcomes. Therefore, what are the? We have 1, 1, 2, 2. In this way, 6, 6, and therefore we'll get 6 entries there. Therefore, probability of success is 6 by 36, and that is 1 by 6. And probability of failure is 1 minus 1 by 6, therefore 5 by 6. Now we have to get at least 3 successes. Therefore, our required probability is 3 successes out of 5 through. Therefore, 5 C3, and therefore this is the probability of success, and this is the probability of failures. And in this way, then exactly 4 success, 1 by 6, and all the 5 successes, this is our required probability. Therefore, if you just simplify, you will get 10, and here I'll take the 25, and you can see 1 by 6 to the power of 5. Here 5 into 5, again 1 by 6 to the power of 5, and here 1 by 6 to the power of 5. If you further simplify, you will get 276 divided by 6 to the power of 5. If you further simplify, it will be 46 divided by 6 to the power of 4, and further simplification, 23 divided by 648, and that is our required probability. Therefore, you see our option D is the correct option. And look at the next problem. Here A and B are the independent event. Therefore, probability of intersection of A and B is equal to probability of A into probability of B. And probability of A is given as 0.4, therefore into PB. Again, probability of A union B is equal to, we know, PA plus PB minus P intersection B. Here you can see that it is given as 0.4, and PB we don't know. It is to be found out, and already we found out this is equal to 0.4 PB. And here it is already given in the question that probability of A union B is 7, therefore we get 0.6. Here 0.6 probability of B and plus 0.4, and from that we can find probability of B as, you can just simplify that 0.3 divided by 0.6, therefore that is equal to half, and that is equal to 0.5, and that is, it is given is 0.5, therefore option B is the correct option. Our next problem is 3 faces of a fair die are red, 2 faces are white, 1 face is black. The die is tossed 3 times. What is the probability that the black, white and red faces appears in the first, second and the third toss respectively? Now you can see the probability of appearing red face. Probability of appearing the red face. Is equal to how many? 3. There are 3 faces are red out of 6. Therefore, this is half. What is the probability of appearing the white face? Is there are 2 faces are white out of 6. Therefore, 1/3. Then what is the probability of black face, appearing the black face? It is 1/6, only 1 faces. Therefore, our required probability is that in the first throw it should be black. That what is the probability of appearing? It is 1/6. Then in the second phase, second throw, it should appear the white. What is the probability? 1/3. In the third throw, it should be red. Therefore, these are our required probability. Therefore, it is the 1/36. Therefore, our option D is the correct option.